In this video, we're going to go through angles in and out of the circle. Some of this you might want to pause throughout, take as much time as you want to copy down the information or to try to understand the problem a little bit more. You can go back, fast forward, it's up to you. Just make sure that you have everything from this video on your paper. As you can see, in the first column is the vocabulary. The middle column is where you're going to do your work or your formula, and the third column is where you will draw the picture of the problem. So we're going to get started. Angles inside, you have two intersecting chords. Angles outside, you have two intersecting secant lines. So these are secants. Excuse my mouse handwriting, but these are secants. And then these are chords. So make sure you understand what creates those. So we have chords for the angles inside, and we have secants for the angles outside. Before we get started, let's do a quick review of what we've covered so far. First one is if the vertex is at the center of the circle. So the center of the circle is P, which is right here. And with the vertex, which is the corner, is at P. So the angle and the arc are congruent. So if the angle is 30 degrees, then your arc is also 30 degrees. So where you have the circle drawn for you, you're going to draw this picture, and then in the middle, put your formula where the angle and the arc are congruent. Pause if you need more time. So it's important to know that the vertex has to be at the center. For the most part, it'll have a center point there unless it tells you it's a central angle or that it's at the center. Second one that we've discussed already is that the vertex is on the circle. So the corner is touching the edge of the circle, and both of these are examples. You can draw each one, you can draw both, it's up to you. This one, the angle equals the arc divided by 2. So if my arc is 100 degrees, then my angle is 100 divided by 2, which is 50 degrees. This works the same way in reverse. It's also your angle times 2 equals your arc. So if in this case we have, let's say 35 degrees, we multiply this by 2 and we get 70. So it works both ways. These are what we call inscribed angles. So the vertex is located on the circle. That's a big key word, that it's on the circle. That arc divided by 2 equals the angle, or 2 of the angles equals the arc. Again, pause if you need more time on this slide. Let's do an example. This says find the measure of angle 1. Check to make sure that the vertex is located on the circle. In this case it is. So all you do is take your arc divided by 2, and half of 84 is 42 degrees. Now, there are 2 examples for this one. You can do this one, which is easier. We have a more complicated one next, so it's up to you as to which examples that you want on this page. So the measure of angle 1 is 42 degrees. Again, pause if you need to. Our second example is slightly different. Again, your vertex is located on the circle, but now we do not know what the measure of the arc is. However, we do know that a circle equals 360 degrees. And together, the arc that is 202, this arc right here, and our arc that we need to find together equal 360. So if together they equal 360 and we know that one is 202, all we have to do is take 202 and subtract it from 360. And so when we do that, we do 360 minus 202, and we get 158. But that is our arc. We need to find our angle. So to find the angle, we look at our formula, which again is the angle equals the arc divided by 2. So our angle is 158 divided by 2, which is 79. So the answer to the measure of angle 1 is 79 degrees. So you can write this one or the last one, it's up to you. Both are great examples. So that's our quick review. Now we're going to go on to the new information. So we're going to review intersecting chords, secants, and tangents. First off is vertex inside the circle. Right here we have our angle. It says angle. And the way I like to do this is I like to draw a line through that angle so I can see which two arcs make up that angle. So arc AB and arc DC make up this angle. And we've already talked about vertical angles. We understand that vertical angles are congruent. So these two angles are congruent. And then we also know that these two angles are congruent to each other, but they're not congruent to the other ones. So we're focused on this white angle right here. So the formula is basically the average of your two arcs. And if you look closely, this kind of looks like a plus sign. So if I circle this inside, it looks like a plus sign, telling you to add your arcs. So again, this is a formula that you have to memorize. So if you think about it just as a big plus sign, it'll help you remember to add the two arcs and divide by 2. As I said, if they're not equal, they're always pretty much you're going to divide your arcs by 2. So in this case, we add the arcs, divide by 2. So make sure you write down your formula. You have this information for you. And then we are going to do an example. So on this one, we're trying to find the measure of angle 1. Again, these two angles are vertical angles, so they're congruent. So it doesn't matter which one you're finding. It's the same for both. I'm going to draw a line through my angle so I can see which two arcs make up this angle. And you'll see why in one of the next examples. So this 93 degrees and this 113 degrees, the average of these two arcs make up the angle. So we take 93 plus 113 divided by 2, and we get our answer, which is 103. Again, you can put this in the calculator, use your fraction key. 93 plus 113 divided by 2 gives you 103. So this is how you do angles inside the circle. We're going to do 2 more examples. You can choose which one to put for the next example, because there's only space for one. You can put them both in there if you want to. That's up to you, but you can choose which one. Obviously, it's going to get a little bit harder, so if you want the harder one for there, you can just wait and watch in the next part. On this one, ignore the question marks. Those are degrees. This time, we're not trying to find the angle, we're trying to find the arc. So again, I'm going to draw a line through the angle so that I see QT and NM make up the angle 92 degrees. So we're going to set up an equation. Our angle, we know the angle equals arc plus arc divided by 2. So we sub in our values. Our angle is 92 degrees, so we're going to sub that in for the angle, equals one of the arcs. It doesn't matter which one goes where. The only one we know so far is 84, so I'm going to put that first. 84 plus the other arc, this is our unknown, so we're going to give it x, divided by 2. And from here, all we do is solve the equation. We always get rid of denominators first. We can't touch 84 degrees and x at the moment because it's blocked by this 2. So we're going to multiply by 2 on both sides of the equation. So 2 divided by 2 is 1, they go away. And we're going to multiply 92 by 2. And you get 184. So 184 equals 84 plus x. Now to solve this one, we're trying to get rid of this 84. So we do the inverse operation, which right now is a positive 84. So we want to subtract 84 on both sides. And when we do that, we get 0 here. So we're left with x on the right side. And 184 minus 84 gives us 100. And so the measure of arc QT equals 100 degrees. Again, pause if you need more time. All you do is take the information they give you and sub it into the equation. So again, our angle is 92. One of the arcs is 84. The other one is our unknown, which is x, and we're always going to divide by 2. The next example for this, we're trying to find x in this problem. This problem specifically is why I suggest you draw a line through the angle so you can figure out which 2 arcs you're looking at. So we have this arc, which is 45 degrees, and we don't know what this arc is. Now, there are 2 different ways to do it. It's totally up to you. First way is we know a whole circle is 360 degrees. We know what 3 of the 4 arcs are in this circle. So we can subtract each one and subtract 45, 93, and 89 from our whole circle, which is 360 degrees. And we get 133, meaning that our missing arc is 133 degrees. Now we have the pieces to find our angle. So we take one of our arcs, which is 45, plus the other one, which is 133, and divide by 2, and that gives us our answer, which is 89. Now the other way you can do this is we can determine what these 2 angles are. So if I draw a line where these 2 angles are, I get 93. Again, this is another way. If you don't want to watch this part, you can skip ahead. 93 plus 89 divided by 2 gives you those 2 yellow angles. And we get 91. So this angle right here is 91 degrees. Sorry, I can't see that. This one is 91. Well, we know that linear pairs, which are these 2 right here, equal 180. So if we do 180 minus 91, we get our angle, which is 89. Both of these are multi-step solutions. It doesn't matter which way you solve it. It's totally up to you as to how you visualize this problem. So that's how you solve for x. There's 2 different ways. Again, it doesn't matter which way you use, you still get the correct answer. So this was angles inside, where you add the arcs to get the angle. Now we're going to look at angles outside. And this one's different. This one doesn't look like a plus sign. So if you remember plus sign, you add them. Doesn't look like a plus sign, so you're going to subtract. So the formula for this one is large arc minus small arc divided by 2. As long as you remember it's the large one, and the reason why it has to be the large one is you'll get a negative number if you do this wrong. So it's large arc minus small arc divided by 2. So here we have 2 tangents. Here we have, those are two secants. Here we have two tangents. And in this problem, we have a tangent and a secant. So you can see it either way, they're still the same problems. Doesn't matter how they look. So we're going to look at an example. This first one, we have two secants. We're trying to find the measure of angle 1. And this is hard to see. This is 65 degrees. So we're going to solve for the measure of angle 1. So we do our large arc. So this, again, I'm going to write down the formula. Our angle equals arc minus arc divided by 2. So again, it doesn't look like a plus sign. So instead of adding, we subtract. So if you remember, instead of inside where you add, it's outside, subtract. Now we're going to sub it in. Again, bigger number goes first, otherwise you have a negative. So it's always large arc minus small arc. So angle 1 equals 65 minus 15 divided by 2. And when you do that and put it in your calculator, you get 25 degrees. So the measure of angle 1 is 25 degrees. Again, pause if you need more time. Here we have two different problems as well. Again, it will get a little bit more complicated, so it doesn't matter which one you choose, you can write down both. This time we're not given one of the arcs, we're given the angle. So again, angle equals arc minus arc divided by 2. So the angle in this problem is 27. It equals our large arc we know. So the large arc is 70 degrees. The small arc we don't know, it's unknown, so we're going to give it x divided by 2. This is another solving equation of problem. So again, we have to get rid of the denominator. You always get rid of the denominator first. So we're going to times it by 2 on both sides. The 2's become 1, so we're left with 70 minus x on one side, and then 27 times 2 gives us 54 on the left side. Now, x is negative. We're going to leave this alone at the moment. We're trying to get rid of our 70 degrees. 70 is positive, so in order to move it across the equal sign, if you need to draw your line, draw your line. In order to get the 70 by itself, we're going to subtract, in order to get x by itself, we subtract 70 on both sides. And we do 54 minus 70, and we get negative 16. Now, can you have a negative degree? No. However, if we look at our right side, we see that x is negative, and we can't have that either. So we divide by negative 1 on both sides. The negatives go away, and we're left with our answer, which is x equals 16. So again, you take your information and you sub it in. We have our angle, which is 27, large arc is 70, minus small arc, which is x, and we always divide by 2. One more problem. Gets a little bit more complicated, and you cannot see this angle here. This is 260. So this time we're only given one number, and we're trying to find the angle, but we're only given one number. However, if we look at our image, this whole arc is 260, and we know that we need to find this smaller arc. However, together they equal 360, so we just take 360 minus 260, and we get 100. So our small arc is now 100, and we can now put this information into the formula to solve for the measure of angle 1. So it's large arc, which is 260, minus small arc, which is 100, divide by 2. And that equals the measure of angle 1. When we put this whole thing in the calculator, we get that the measure of angle 1 is 80 degrees. So this is how you find the measures of angles inside and outside the circle. You now have a Google form to complete. Do the same thing. Look at your notes. In that Google form, you're going to answer the questions inside the Google form. So put your answers in there. But on the left side of your paper, you're going to put your work. So you need to draw the pictures so that you can label and find the missing pieces that you need to find and solve the equation or solve for the missing piece. So I need to see the work on the left side of your notebook in order to get credit in your notebook. So please make sure that you follow directions so that you don't miss out on any points. And hope you guys have a fantastic day. Thank you. Bye.